So welcome friends. So in this video we will be doing a project on image classification. So we have a data set from Kaggle. So in this data set we have a list of images of cats and dogs, and we have to predict whether whether an image is of cat or a dog. So what do we have? We have uh, an image with the label. So what does it mean? 1 means dog and 0 means cat. So we have total of 25 images. So there are two things that we need to consider. First is the images are 25,000, so it's a lot of data. So we cannot download this in our local system. So what will we do? We will download it in the Google Colab, and then we will use that data to train our model. So for that, what you can do, first you need to create an account in Kaggle, then go to your profile, then type account in the URL, then go to API. Just create a new API. When you create an API, it will download a kaggle.json folder, just like this, kaggle.json. Then what you need to do, the first thing, we will import Kaggle. So sorry, first we will install the Kaggle, and then we will ask to upload our kaggle.json file. It's connecting. Just wait. Then choose a file, click on Kaggle. So it has done. So our kaggle.json has uploaded here. Now what will we do? We will set up the Kaggle. We will what we will do, we will paste that kaggle.json here in this file. Yeah, here it is. And then we will make the directory mkdir Kaggle and Kaggle.json. So what we are doing here, we are giving the permission Kaggle.json of read and write to the owner. So chmod command is used to give the permission to the owner group or other people. Okay. Then what we will do, we will download the data set from Kaggle competitions, download. We have dogs versus cat, dogs versus cats. And wait, it will download the zip file. So we have the zip file here. So what we need to do, we need to unzip it. Let's unzip it. Unzip uh, dogs versus cats dot zip, and we need it in the data set. So what this command will do, this command will unzip the file and put it in the data set. So we have test and train. So we will use any train data to test as well as train our model. Okay. So only the train.zip has enough data to train our model. It has 25,000 images, so we will use that. Okay, then we will unzip our train data. So our data has been unzipped. We have the data here, all the images of cats and dogs. Let it input. It will take time. Okay, so before moving further, I need to tell you a concept of the image. So how we will do it? So let's suppose we have an image of 3 by 3. Let's consider that one cell is of represents 1 pixel, and we have total of 9 pixels. Let me draw a border here, a thick border. Okay, then uh, each pixel represents the color. Let's say it's a orange color, blue, any color, like random. I'm giving a random color. So all these pixels will create an image. So one more thing, that each pixel has an RGB value from 0 to 225. So suppose we have here we have the black. So black has the RGB value of 000. Okay, and suppose we have here we have red. Suppose so R will be 255 comma 0 comma 0. Okay, so it will create, it is a 2D matrix. We can say it as a 2D matrix, and each cell represents here a pixel, and each pixel has a RGB value. Okay, so what we will do, we will give that image, it will convert that image, we will read that image as a RGB value. So we will have 255 comma 0 comma 0 0. Then suppose it's brown. I'm assuming that uh, it is 2 2 2 2, just a random values. And then we have blue, suppose 0 comma 2 to 5 comma 0, and so on. So what we will do, just let me take this one as well, and so on. Okay, then what we will do, we have the matrix 3 by 3. We will convert this matrix into an array. So what the array will be, the array will be like 2 2 245 comma 0 comma 0 comma 234 comma this matrix 2. I just forgot to add 2, that it is wrong. 234 2 comma, let's say the, okay, so it will be 234 234 comma 2 comma 2 comma 0 comma 0 comma 0 comma 0 comma 225 comma 0. So what I'm doing, I'm going in a row measure wise this. Okay, so we will convert a 2D matrix into 1D matrix. Okay, that 1D matrix will be used as a feature for our models, and it will be used to train our model. Okay, so that's the whole concept. So at the end we will having only the 1D array. Now coming back to our model, so as you can see we have all the images, all the 25,000 images. Now what will we do, we will convert our images into the numerical form. So first we need OS, then we will import CV2, then we will import numpy as np. So CV2 is that library that will convert our image into numerical form. Now we will create a function named as load images. We will pass the folder path of the folder and we'll pass the limit. We have 25,000, let's take 25,000 images only, and then we will write the definition. Let's say we have images as empty array and labels as empty. Label will have the answer 0 or 1. Images will have the vector array or numerical values, you can say. For index comma file name in enumerate folder is correct. We have the limit img dot if index is equal to, yeah, image image path will be equal to, I will explain all the code, let me just finish it first. Dot folder dot file name, then we will convert the image img is equals to cv2 dot im read im read, then we have image path comma cv2 dot im read grayscale, yeah. Then we will we will check if our image is there or not. If img is not none, okay, then what we'll do, we will add a label. Label will be equal to 0 if we have a cat in file name, else it will be 1. Then we will append the image dot flatten, and then we will we have the label, and then we'll return np dot we will return in numpy. Okay, so what I'm doing here, let me just run it. So what I'm doing here, we have an empty array, images and labels. So images will contain all the numerical values and labels will contain 0 and 1. So we have a limit as 25,000, that not more than 25 images can be input here. We have a total of 25. You can uh, use less data set as you want, but I'm using 25,000 images. Okay, then I am extracting uh, the folder where all the images are there. Then I'm converting that I'm what I'm doing by I'm converting, not I'm sorry, I am reading the images in a grayscale mode. So why grayscale? So grayscale will reduce the size of the image. So if it is colored, it will take more, you can say more data, but in grayscale it will take less data. So I'm reading that, converting that image into the grayscale, and then using this statement I am converting that image into a numerical form in this form. Okay, and I'm also checking the label is cat, it will be 0. If it is dog, it will be convert to 1. Okay, then I'm returning the numpy array. Then what I will do, I will take two variables, x for features and y for labels, and load data set dot train, and one more with train. We have okay, yes, good. Then comma limit will be equals to 25,000. Let's run it. Okay, think it's one. Let's look. It will take time because there are 25,000 images. Let's print the number of rows. What it says. So there is an error. So what the error says? The images are not homogeneous. It is inhomogeneous. So we have to fix what we have to fix the number of we have to fix the size. So let me explain the error first. It is important. Excel. So what we did, we suppose we have an image of 2 by 3 and another image of 3 by 3. So thus their sizes are different. They will have a different memory. You can say a different space. So the one with the less dimensions will take will have a smaller array size, and one with the bigger image will have a greater array size. So it is inhomogeneous. So to make it homogeneous, what will we do? We will fix the image. Let's say let's say 64 by 64. Let's run it again. Now it should work. Let's see. It will take time. It has a lot of data. Now it is done. So there are total of 25,000 images. Okay. Now coming back to the projects. Now what we can do, we have to visualize the images. Okay, we have to see what the actual images are. How does see how what does X contain? Okay, so what we will do, we will import matplot as plt. Then we will create a function for that. Let's say show images. Then we will pass our image, our label, number of images that we want to show. Then we will set the figure size, figure size plt dot fix size. Let's say 10 by 5. Then for I in range of this, it is correct. We have we don't require this. And label, let's say it's at uh, it will contain 0 and 1. So to make it more readable, what we can do, if it is, let's say dog, if my label is 1, if my label of I is equals to 1, else it will be cat. And the access boost, let's see. And now what we need to do, we have to show our images. So we will call the function show image, and we will pass our data x comma y. Let's say we want to see 5 images. What it says we don't have a label. So what we have labels. Okay, my mistake. And then again, so these are the first 5 images. We have cat, dog, and dog. These are the data set that we have. Okay, now cool. What we can need to do, we will now train our model. So we can use multiple algorithms. We can use logistic regression, XGB classifier, SVC, or random forest. So in this video, we will do it with two algorithms, random forest and XGBoost. So first doing with the random forest. So from sklearn dot model selection, I will import train test split selection, import train test split, and then from sklearn accuracy score. I mean, you don't need logistic. You can do it with logistic regression as well. Dot matrix. We have matrix. Then we will import for random ensemble. Import random forest classifier, and we have accuracy. Yeah, this all these we need. Then I will split our data into training and test set. Xtrain, xtrain, xtest, ytrain will take us to. So then let me explain it first. So train test split is a library that is used to split our data into test and training data. So we are taking 20% of the data as test data, and rest of the 80 data, 80% of the data will be considered as our training data. Okay. Then we have the random set. Let's do it for random set. It defines the it selects the number of rows randomly. So this it's just a numerical random number. That means every 40-second uh, row will be selected from the data set. So it is selecting the randomly. Okay. Now what I can do, I can let me just print. Let's see is it splitted or not. Yes. So our data has been splitted. We have 20,000 in as a training and 5,000 as a test data. Now we will train our model is equals to x x. We have the random forest classifier, then model dot fit. Now it will take some time. Let's write code to find the accuracy for a training data first. Okay, then we will predict it for the test data. So we have train data prediction is equals to model dot predict xtrain and train accuracy score is equals to uh, accuracy score we have ytrain comma train data prediction. What is yeah, then we will print accuracy score will be equal to, we have, I think we use train data accuracy. So what I'm doing here, I am predicting the values for the training data, the same data that we use to train our model. That I am finding the accuracy score on. So what it will the line number second, what it will do, it will match all the values 0 1 0 1 0 1. Suppose we have first five rows are 0 0 0, so and train has 0 0 1 0 0, so it will give the accuracy score as 80% because one value is incorrect. Okay, so that's how it will go. Now let's wait to finish it. You can also decrease the number of images if it is taking too much of time. So I will skip the time. So our model has been trained. It took around 5 to 10 minutes. Okay, now let's see. What's the accuracy? Accuracy is 100%. Okay, let's go it. Now we'll do same for the testing purpose. So we will name as test data prediction, and we will use test data, and same goes with the, we will find the accuracy for the test data. We have test. So accuracy is coming out to be 64.24%. That is fine. That is fine. And any accuracy more than 70% is considered as good. But our accuracy is 64%. That is also kind of good. So you can also consider different model. Let's start with the XGBoost. From XGBoost, import XGB classifier, and for the classifier what I can do, I can just replace it. You can create another model, but I'm editing here XGB classifier. You can also add some parameters like n estimators and all other things, but I'm not adding here. What it says is not, if okay, I have not. Wait a minute, let's do it again. Done. Now we wait. So our model has been trained. The accuracy score on training data is 99.47%, whereas in test data we have 66.74%. So it has improved. You can also check, add some different parameters to the model to improve the accuracy, like an estimator, or that shows how many trees that you want to add. So that's all for now. So if you have any query regarding uh, this project, do let me know in the comment section, and don't forget to like and subscribe. Thank you.